research group. As I mentioned, I took over the lab in 2013, but we are approaching about 40 years of continuous data collection on the central Florida coast, on the beaches. We are also approaching close to 40 years of coastal juvenile in-water work. So remember, those little baby hatchlings, they emerge from the nesting beaches, they travel offshore for an undetermined period of time known as the lost years, and then eventually they make their way back into coastal waters, into places like the Indian River Lagoon. And that's where we have a very long-term in-water sampling program that, in fact, there's a gentleman in the audience right now, Bill Redfoot, who was one of the folks that's worked on that project for a very long period of time. And I'll go into a little more detail in a few minutes. And then as I joined the UCF Marine Turtle Research Group in 2013, I brought with me a lot of the work that I had been doing after I received my PhD offshore. And that's what I'll tell you about in more detail, is how we're solving the mystery of the sea turtle lost years. We have out on the central Florida, southern Brevard County area, we have a field station. We have a long-standing relationship with what is now the U.S. Fish and Wildlife Service's Archie Carr National Wildlife Refuge. And data from the UCF turtle program back in the 1980s and early 1990s were used to establish the Archie Carr National Wildlife Refuge. And we have right now a memorandum of understanding with them. They have granted us use of a bunkhouse, which we use as our base of operations in the summer months. We monitor every about 47 kilometers of beach from Patrick Air Force Base, right as you come across the Pineda Causeway, a little bit further north of there, of that Pineda Causeway and A1A kind of junction. We monitor from there all the way down to the Sebastian Inlet. And just probably about a kilometer north of the inlet, we don't monitor the last bit, which is the Sebastian Inlet State Park area. But everything in between, we pretty much monitor and have been monitoring since the very early 1980s. That lower portion, the lower 20 kilometers of beach, is the Archie Carr National Wildlife Refuge, at least the Brevard County portion. And that 20 kilometers of beach we monitor at night. Everything else we do, including the Carr Refuge, we also monitor during the day. And that little red star up there on the map is our home base, and we have a whole bunch of trucks and ATVs that we use to deploy every day during the nesting season to monitor and count how many nests are being laid up and down the coast of central Florida. One of the probably most amazing experiences, and if you have never seen a sea turtle nesting, I strongly recommend that you take the time to go out to the coast during the nesting season. And if you can, go out this year, because it should be a very exciting year for green sea turtles. And I'll tell you why in a minute. But for the early part of, and kind of like the end part of a sea turtle life cycle, the females will emerge after dark, they'll crawl up on the beach, and they'll select an area where to lay their eggs. They will initially clear off the soft sand, they'll build something called a body pit, and then they use their rear flippers to alternate and kind of take a scoop of sand, stick it over to the other side. They'll change their flippers, take a scoop of sand, push it off to the side. They'll do that until their rear flippers can't really scoop any more sand. And what's really cool is that Melissa Gonzalez is also in the audience. She was one of my first interns when I took over the project. I think she was my second full summer. And so if you have any questions about sea turtle nesting behavior, she's a good person to ping after the seminar. So the nesting portion of the sea turtle life cycle is pretty exciting. And as I mentioned earlier, it's probably the aspect of sea turtle life history that we know the most about. It's the most accessible because it's easy for us to access a beach count the nests or even count the number of females coming up, and to see what the reproductive output is based on how many eggs are in the nest and or how many hatch out. This is a video that shows, it's a time lapse of about 40 minutes, looking just kind of north up the beach from Ponce Inlet, or Ponce Landing, just in Melbourne Beach, just south of that Publix where that guy won the couple won the lottery a little while ago. Unfortunately, it was not one of our students. Our field house is just south of there. And it'll loop back again. But just looking up, and you can even see up in that top bit that there are all these turtles. Those are mostly green turtles that are coming ashore to nest. And that stretch of beach in the Archie Carr National Wildlife Refuge, in that southern 20 kilometers that we monitor just before the Sebastian Inlet, that stretch of beach is the most popular stretch of beach for sea turtles in the Western Hemisphere. That is where we have the most loggerheads nesting in all of the Western Hemisphere. And we have green turtles that are increasing in their nesting numbers over time. And those green turtle nests now represent about 12% of all the nesting in the Western Hemisphere for green turtles, where 85% occurs on a beach in Costa Rica known as Tortuguero. You may have heard of it. So we have the second most important nesting beach for green turtles just in a 20-kilometer stretch of beach, and that is it. But that gives you a bit of an idea of how crazy it is. We have turtles coming up and coming up and coming up. You have to make sure you hit the restroom before you get out on the beach, because once you're out there and a turtle comes up, you can't move. You have to wait for them to get up into the dunes to start doing their thing. Otherwise, they might get spooked and turn around and go back and do what's called a false crawl, where they don't actually lay their eggs. They'll crawl up and crawl back. And so you can get trapped out there. One of my first summers, I learned the hard way. Now we have 3 main species that we have nesting on the beaches that we monitor. We have leatherbacks. Leatherbacks are very cool animals. They have kind of a leathery skin that covers their shell. If you take just one of the panels of the doors, add a head and flipper to that, that's about the size of a leatherback. They're huge. We also have loggerheads, and loggerheads historically were the most common species on the beaches that we monitor. And the loggerheads, they're a little bit smaller. They might be maybe about this tall on the podium down to the floor, with a head and flippers, maybe a little bit wider. And then the green turtles might be a little bit bigger. They might be about as big as this podium with a head and flippers attached to it. But those 3 animals, those 3 species, are the ones that we typically see nesting on the beaches. The leatherbacks show up starting in March or April. The loggerheads start showing up late April, early May, and then the greens start showing up in May and into June. And so each of those turtles, their nesting peaks at a slightly different time as well. So it's kind of nice, but it also makes for a pretty crazy June and July for us. Each of those species has a very distinctive track that they leave in the sand, and so it makes it easy for us to drive up the beach first thing in the morning as soon as the sun is rising to count all the different tracks, but we can also identify each track to the species. Their nest site also looks very different depending upon what species laid the nest as well. Our nighttime work, and we do both nighttime and daytime work, and this is one of the coolest aspects of the job that I took over for the lab. And we have a very active and amazing group of interns that we have out there every single year. We usually bring out 10 to 12 new interns. They're all UCF undergraduate students, and they go through a pretty intensive selection process. Once they work with us for a summer, they're often invited to return and work with us for an hourly rate for as many months or summers as they're interested in, or until they graduate and move on. But it's pretty incredible, and I think, in fact, is this you, Melissa?
I think that's Rachel.
Was it? No, I think it was you.
Yeah?
Yeah, I think.
I want that.
That's kind of fortuitous. Anyway, but we have the interns out there. They're doing everything. They're handling the turtles. They're measuring them. They're taking samples from them, tissue samples. We do a lot of work looking at the genetics of the animals. We're looking at disease ecology. We are looking at the chemistry of the tissue, stable isotope analyses. You are what you eat, so we can tell a little bit about where the turtles had been eating up until a month or two before they nested, based on the chemical signature of their tissue. So we just take a tiny little biopsy. If you've ever been to a dermatologist, you might have had a biopsy taken. It's the same concept. We have all of the interns are also involved in tagging the turtles. So each of the front flippers of the turtles will receive a cattle ear tag, and then we inject into the front right flipper of every turtle a pit tag, which is the same thing as what vets use to chip animals. So it's a passive integrated transponder tag. It's about the size of a tiny grain of rice, and we use something that looks like a bit of a paddle to scan over the flippers, and it'll pop up about a 14 or 16 digit number that is unique to that animal. So that's how we can keep track of individuals and their nesting activity over time. But we involve our undergrads in all of this, and we look to get undergrads who may not have had a lot of research opportunity. We try to encourage we try to bring in students who haven't been able to work in a lab yet, and we don't look for perhaps the most straight A student. We're looking for students who are looking for an experience, that are hard workers, that have a strong work ethic, and can stay up at all hours of the night or day, covered in sand, bug bitten, and still be really excited about what's happening on the beach. This is a picture of a leatherback. It gives you an idea of how big they can be, and it was a time series image from last summer, and that's some of the field gear that they use and some of the tags up in the upper left-hand corner. And as I mentioned, on the nesting beaches, we also monitor the beaches during the day. So every single morning, we will get the crews out. They'll drive to, or they'll take a truck with an ATV to a different point up and down that 47-kilometer stretch of beach. And they will put an ATV on the beach and drive in one direction, so we cover everything in the morning. We'll count how many turtles crawled up on the beach, how many nests were laid, and then later in the summer we start to monitor some selected nests. We'll subsample and we'll mark some nests, and we'll start monitoring those for hatching. And as I recall, if you recall earlier, I was talking about shifting baselines. And this is just a graph of green turtle nests over time, from the time that my predecessor started to really hardcore monitor the beaches out of the coast, from early 1980s, 1982 until 2017. And I need to actually add in the last couple of years, but 2017 was the last really large green turtle year. Weirdly, green turtles nest, and this happens all over the world. They'll nest in high years, followed by lower years. High years, lower years. We have no idea why that happens, but it happens. So back in the 1980s, green turtles on the beaches that we monitored, in particular that southern Archie Carr National Wildlife Refuge, those 20 kilometers of beach, early in the 1980s, they had maybe 30 or 40 nests. Back in 2017, we had close to 16,000 nests. This is an incredible, exponential, so far, increase in sea turtle nesting by green turtles on that coast. Now, back in the 1400s, back when Ponce de Leon was first encountering this part of the world, there were ship's logs that state that there were so many green turtles that you could walk across the shells of those turtles between his boats. And over time, those turtles were harvested. They were locally extirpated by the 1600s. There was a fishery out of Bermuda, and Bermuda hasn't had sea turtle nesting since the 1600s or 1700s, thereabouts. But we're slowly starting to see a turtle come back. And I'm kind of interested to see what happens. Maybe, this is Doc Earhart's career span. Flip that out to another 20 years by the time I'm ready, hopefully, to retire. And who knows what those turtles are going to be doing by then. It's kind of exciting. But then think back. I mean, what was going on in the 1800s? We don't know. Those beaches were never monitored. And back to the 1600s. But if you translate this into, if you think about it, this is also, that red bar is one career span. It's also probably one turtle generation. And if you think about that in terms of multiple turtle generations, that might only be about 8 turtle generations. And what goes, going back to the 1600s, that could be far, far more. But we only really have an idea of what's going on since the 1980s. We don't know what was going on prior to that. We can read about it in ship's logs, but it's not really quantified. So this is also kind of an example of those shifting baselines, because we just assumed that in the 1980s that there just weren't green turtles nesting there. But they used to. We just lack that information, and we lack any record of that. Now moving from the nesting beach, we're going to skip the offshore just for a second while I finish out giving you an idea of what the UCF program does in coastal waters. And as I mentioned, those turtles, after they've spent time in the open ocean as those little babies,